There is an invisible chemical that's pretty much everywhere in our food, our soil, even our water. It's the most common weed killer on the entire planet. But some really recent science is starting to pull back the curtain on a pretty disturbing secret: what it might be doing to our brains. So that brings us to the big question we're going to tackle today. How is this chemical, something that was just designed to kill weeds, potentially harming us in ways we're only just starting to wrap our heads around? The answer? Well, it's as fascinating as it is unsettling. So, first off, what is glyphosate? The easiest way to think about it is like a pair of magic scissors. It's great for trimming away unwanted weeds, but here's the catch. These scissors, they're not always that smart. Sometimes they can accidentally start snipping away at the very delicate, super intricate systems inside our own bodies. And the scale of this is, well, it's staggering. We're not talking about some rare, obscure substance. This is the world's #1 herbicide. It's in the environment, which means we ingest it. And this is the really crucial part: research shows it has a direct access pass to our brain because it can get right through the super protective blood-brain barrier. Okay, so what happens once it's inside? Well, picture your brain as this bustling, perfectly organized city, right? Signals are traveling smoothly, everything's working. Glyphosate acts kind of like a jammer, broadcasting this chaotic signal that just messes everything up, causing all sorts of confusion and disorder. Let's dig into how that actually happens. This whole invasion unfolds in about 4 key stages. First, like we said, it breaches the brain's defenses. Then it triggers an inflammatory response. Think of it like the city's emergency services just going haywire. Third, it starts messing with the actual construction and upkeep of the nerve pathways. And the result of all that? Neurological dysfunction. And listen, this isn't just some abstract idea. This chaotic signal creates very real, very measurable problems for our health. So what does that damage actually look like for a person? The difference is pretty stark. A healthy brain, you've got clear signals, sharp memory, a stable mood. But a brain affected by this, we're seeing chronic inflammation, memory decline, and cognitive impairment. Studies are even pointing to an increase in specific inflammatory markers, things like TNF-alpha, which are directly tied to neurodegenerative diseases. Now, in the short term, right after you've been exposed, the symptoms can be the kind of things you might just brush off. Headaches, feeling a bit dizzy or foggy, finding it tough to concentrate, maybe even some weird mood swings. These are the first little warning flares that the jammer is at work. But the real danger, that lies in the long-term exposure. This isn't about one bad day. It's about the slow, quiet, chronic damage that builds up over time. We're talking about a higher risk for serious cognitive dysfunction, depression, and, yeah, even some of the scariest neurodegenerative diseases out there. Okay, so if an adult brain is a bustling city, a child's brain is a city that's still under construction. And that, right there, makes it uniquely vulnerable to this kind of disruption. This is an absolutely critical point. Here's a really helpful way to picture it. When you're building a house, every single material matters, right? So throwing a disruptive chemical like glyphosate onto the construction site during this critical building phase, well, it doesn't just make a temporary mess, it can cause permanent structural flaws in the brain's final design. So, what do those flaws actually look like? Well, it can mean abnormal nerve cell growth, which could lead to things like attention deficits and learning difficulties. It can mess with the formation of the myelin sheath. That's the vital insulation that goes around our nerves. The potential ripple effects on a person's entire life, they're just profound. So with all this information piling up, the science has really been pushing forward, trying to get the full picture. And some very recent findings have added a whole new layer of urgency to this entire conversation. And that leads us to what is honestly the most pressing question of all. If we stop the exposure, if we turn off that jammer, does the brain heal? Can the city restore order? The latest science has a pretty chilling answer. Here's the bombshell. Breakthrough research from just this past year has found that the damage continues. Even a full 6 months after someone stops being exposed to glyphosate, the inflammation and the dysfunction inside the brain, they're still there. In fact, the way the researchers put it is that the damage isn't like a bruise that just fades away. It's more like a scar that's left on the brain, a lasting mark that is incredibly difficult, if not impossible, to fully heal. And that's exactly why this is such a tricky issue. See, glyphosate isn't like a classic fast-acting poison. Its danger is way more subtle. It's a chronic, hidden threat that just quietly chips away at our health over years and years through inflammation and by disrupting development. So, given everything we now know, certain groups are clearly at a much higher risk. We're talking about pregnant women because of that developing fetal brain, children, of course, whose brains are in that critical construction phase, and agricultural workers who are on the front lines with the highest levels of direct exposure. So, what can we actually do? Well, the recommendations all focus on one thing: reducing your exposure. That can mean choosing organic foods when you can, being more mindful of where your food is coming from, and supporting farming practices that don't rely on these kinds of chemicals. Look, the whole point of this and of all the research behind it is absolutely not to create panic. It's about empowerment. It's about fostering scientific literacy so we can all make informed choices and push for rational protections for ourselves and for the next generation. Which really leaves us with one final thought to chew on. Knowing what we know now, that the health of our environment and the health of our own brains are so deeply connected, what choices are we as individuals and as a society willing to make to protect both? That's a question worth thinking about.